Okay, problem 34. Write an equation relating the variables. Use k for the constant of variation. Letter A says that S varies directly as R. We want to remember that whenever something varies directly, we're going to multiply, and whenever something varies inversely, we're going to divide. So this one's just going to be S equals KR. B is going to be Y equals K divided by X. Letter C is a little different because it says T varies directly as R and inversely as X. So we're going to have T equals, then we're going to put our constant in K, directly as R. So times R and inversely with X, with S times S. V varies jointly with R and H. We want to remember that jointly and directly are the same thing. So it's just going to be V equals our constant K times RH. Number 35. If y varies inversely as x and y equals -2 when x equals 25, find x when y is -40. Well, for problem 35, we want to use our formula y equals k divided by x because they vary inversely. So we're going to put -2 in for y, k is k, and x is 25. If we multiply both sides by 25, we get -50 equals k. So, find x when y is -40. So we're going to say -40 for y equals -50 for k and x for x. And I'm just going to set this up like a proportion. Now when I cross multiply, I'm going to get -40 x equals -50. And when I divide, I'll get x equals 5/4. Alright, number 36. The time t required to empty a pool varies inversely with the rate R of the pump. One pool takes 60 minutes to empty at a rate of 230 gallons per minute. Write an equation that represents the relationship between t and R. Alright, well, the first thing we want to start with is time equals k divided by rate. As the rate goes up, the time will go down. As the rate goes down, the time needed will go up. So if we know it takes 60 minutes for a pool that is 200, oops, I forgot my constant, for a constant divided by 230. I'm going to grab my handy dandy calculator and I get a multiply both sides by 230, 60 times 230. I get a constant of 13,800. So actually, I guess what they really want just for A is just this, which is kind of stupid. And then here's our K. Alright. So how long will it take to empty the same pool if a pump can empty at a rate of 300 gallons per minute? So here we go. Now we're actually going to use this. So it's going to be time equals our constant divided by our rate. And if we divide those, we get about 46 minutes. Alright, 37. Graph each function. Label the horizontal and the horizontal and vertical asymptotes. Identify the x and y intercepts. State the domain and range. Something tells me this is not going to be enough room. Okay, now we have more space. So the first thing we're going to do is look at the denominators, and that's going to give us our vertical asymptote. We're going to find the vertical asymptote by setting the denominator equal to 0 and solve. So if I set this equal to 0, I get x equals 4. If I set this equal to 0, I get x equals 3. If I set this equal to 0, I get x equals -1. Subtract 3, x equals -3. And in real quick, I just got all of my vertical asymptotes. So these are all my vertical asymptotes. Now, as soon as I have my vertical asymptotes, I also have my domain. The domain is going to be all real numbers, but x cannot equal that vertical asymptote. So this is my vertical asymptote. Vertical asymptote, domain, all reals except 3. Domain is all reals except negative 3. And the domain is all reals x cannot equal negative 1. So there's our domain. Now, just as quickly, we can do the range. You'll notice we have two types of problems here. We have problems where there are x's in the numerator and the denominator, like b and d. And we have problems that don't have x in the numerator and denominator. The way we can find a horizontal asymptote without our calculator is we look either at two situations. If we have a situation like b and d, all we need to do is divide the leading coefficients. So here I have a 1x and 1x. So my horizontal asymptote is going to be y equals 1 divided by 1, which is 1. And that means my range, is going to be all real numbers, y cannot equal 1. Here I have 4 and 1. So my horizontal asymptote is going to be all real numbers. Sorry. I got a little ahead of myself. My horizontal asymptote is going to be y equals 4. Go away. And the range is going to be all real numbers. Y cannot equal 4. Okay, so that's the first situation. The second situation is if I only have x in the denominator. If I only have x in the denominator, it's just going to be any constant I have outside. So here, I have no constant outside, so that's like a plus 0. So my horizontal asymptote is going to be y equals 0. And my range is going to be all real numbers, y cannot equal 0. Here, I got a 4. So my horizontal asymptote is going to be y equals 4. And my range is going to be all real numbers, y, what was that? Y cannot equal 4. Okay, so I've done all the properties except the x and y intercepts. Let me grab the calculator. Alright, so here we go. I'm going to grab my calculator and I'm going to type in a. And we've got 2 divided by parentheses x minus 4, close parentheses. So pause it if you need to see that screen for a second. Then I go look at my graph. Wait, I gotta change something. Got some Algebra 1 settings. Don't want that. It's hurting my eyeballs. Alright, so there's our graph, and we can see we have our vertical asymptote at 4 and our horizontal asymptote at 0. And we just need a little more information. Well, first off, I can see I have no x-intercepts. So I'm going to say that. Now, I have a y-intercept here, and the fastest way to find it is to just look at my table. I say look at my table, and go up to where x is 0. And I have a y-intercept at negative 0.5. Now I want to point something out, and that is right here where you see that error at 4. That's because we can't divide by 0, and that's why it's a horizontal asymptote, or vertical asymptote, sorry. So now we're going to get a really quick sketch in, and honestly, these sketches that I'm going to make are going to be pretty bad. Let's make some axes here. There we go. Alright, now when we look at our table, we see we have a vertical asymptote at, or we know we had a vertical asymptote at 4, 1, 2, 3, 4. So we're going to put a dotted line there. We have a horizontal asymptote at y equals 0, so we're going to put a dotted line there. Now we just have to see how to fit these curves in. So I have a couple good points. I have one at 2, negative 1. And I have one at 3, negative 2. So here's one curve. And then I've got one at 5, 2. And at 6, 1. Not bad. Alright, next graph, B. I'm going to go back to y equals, and I'm going to have x plus 4 divided by x minus 3. And I want you to notice that my numerator and denominator are in parentheses. So now I think I have an x-intercept here, so I need to find it. So the way I'm going to find this x-intercept is I'm going to go to second trace, and I'm going to pick number 2. I'm going to pick number 2, 0, and I'm going to move my cursor to the left of the 0. I know I'm on the, there we go. I know I'm on the left when my y value is positive. I'm going to press enter. I personally just like to type in a number, so I know that -1 is to the right. I'm going to put -1 in, and you can see I have my arrows on each side, and it's somewhere over here. I can press enter for guess. Hey, -4 perfectly. So I have an x-intercept at -4. I have a y-intercept at 1.3 repeating, as I know is 4/3. -4. Now I'm just going to get my graph in. I have my vertical asymptote at 1, 2, 3. I have my horizontal asymptote at 1. I have a couple good points. I have a point at 2, -6. I know I have my intercept point at -4. And I'm going to get my curve in there as best I can. And I'm going to go a little bit over. So I've got, I'm going to go with 4, 8, 1. It's going to be off. So let's go with 5, 1, 2, 3, 4, and a little more is up here. You can imagine it's there. Ideally, I would have a really good point, but I kind of didn't allot myself good space. Alright, next 2 graphs. Let's take a look at C. So we're going to go to y equals, and we've got 2 divided by x plus 1 plus 4. And I see I have an x-intercept here. It looks like it's between -2 and -1. So I'm going to calculate 0. And rather than use the arrows, I'm just going to do -2 and -1 because the computer is slow. And I don't need to guess. And there it is at 1.5. -1.5, and again, to get my y-intercept, we're just going to go to the table, and I have a y-intercept at 6. So I have my vertical asymptote at -1, there it is. I have my horizontal asymptote at 4. I have an intercept at, so I'm going to kind of use that as my guide point here, my y-intercept. Let's see if I can get, there we go, -2, 2, that's pretty good. Okay, last one, letter D. I'm going to go to y equals, I'm going to clear out what I have, and I'm going to put in 4x minus 2 divided by x plus 3. I have, that's a little tricky. Let's get the y-intercept first. Now let's get the x-intercept first. So 0, and I think it's between 0, yeah, definitely 0 because that's negative. I'm just going to put in 2. It's somewhere in the middle there. Oh, and it's 0.5. Or 1/2. My y-intercept is way up there. No, it's not. It's way down there. Hey, I saw that. I knew that. We saw that when we were looking for the x-intercept. And I know that negative 0.666 repeating is 2/3. So I'm just going to write negative 2/3. If you want to write negative 0.6 repeating, that's your decision. All right, here we go. Asymptotes. Y equals 4. 1, 2, 3, 4. Dots across. Vertical asymptote at negative 3. 1, 2, 3. Dots going down. 4, 2 is a good point. 1, 2, 3, 4, 2. I don't really want to, I just kind of want to make it agree with what I know the what I know the intercepts are. And let's think of something that's not huge. Negative 10, 6. 3, 4, 5, 6, 7, 8, 9, 10. 4, 5, 6. And there are our graphs.